Welcome back. Today, our topic is integers. To brush up your basics, please check out integers in Class 6 playlist. Properties of integers. Properties of integers in mathematics are certain rules that can be applied to simplify calculations. When we perform arithmetic operations, like addition, subtraction, multiplication, division, on them. We know, integers are collection of whole numbers and negative numbers, and integers cannot be a fraction. That is. Under properties of integers, we have properties of addition, properties of subtraction, properties of multiplication, and properties of division. Now, let's look into properties of addition. Closure property. Example. Consider integers 1 and 2. Since we are looking into properties of addition, we perform addition operation. 1 plus 2 equals 3. And 3 is an integer. Since addition of integers gives an integer, we say integers are closed under addition. This means you can execute addition operation with any of the integers, and the resulting answer will still be an integer. In general, if a and b are two integers, then a plus b will be an integer. This is called closure property of addition of integers. Commutative property. Example. Consider integers 4 and 5. We perform addition operation. Here, 4 plus 5 equals 9. Also, 5 plus 4 equals 9. So, 4 plus 5 equals 5 plus 4. We can see the integers can be added in any order and the result is same. So we say, addition is commutative for integers. This means, when addition operation is executed for pairs of integers, it gives the same result when the order is changed. In general, if a and b are two integers, a plus b equals b plus a. This is called commutative property of addition of integers. Associative property. Example. Consider integers -5, -6, and 9. We perform addition operation. -5 plus -6 plus 9. Case 1. Let us group -6 and 9 together, we get -5 plus 3 equals -2. Case 2. Let us group -5 and -6 together, we get -11 plus 9 equals -2. We see, in both case 1 and 2, the result is same. Hence, addition is associative for integers. This means, the sum of 3 or more numbers will always remain the same, regardless of how the numbers are grouped. In general, if a, b, and c are integers, then this is called associative property of addition of integers. Additive identity. Additive identity is the value when added to a number, results in the original number. Now, if we add 0 to an integer, say 1. 1 plus 0 equals 1. Also, 0 plus 1 equals 1. Here, result is the given integer itself in both order. That is, 0 does not cause any change in the addition expression. Hence, 0 is called the additive identity of integers. In general, for any integer a plus 0 equals a equals 0 plus a. Additive inverse. Additive inverse of a number is the value which on adding with the original number results to 0. So, we can achieve this when we add an integer to its opposite. Example. Consider an integer 2. 2 plus opposite of 2 is -2 equals 0. Or -2 plus opposite of -2 is +2 equals 0. So if a is an integer, then -a is the opposite, and vice versa. Hence, property of 1. Addition of 1 to any integer gives its successor. Example. Consider an integer 7. 7 plus 1 equals 8. Here, 8 is the successor of 7. This ends our topic on properties of addition. In the next video, we will cover properties of subtraction. Welcome back. Let us continue with integers. Properties of subtraction. Under Properties of subtraction. Closure property. Example. Consider integers 4 and 8. We perform subtraction operation. 4 minus 8 equals minus 4. Since subtraction of integers gives an integer, we say integers are closed under subtraction. In general, if a and b are two integers, then a minus b will be an integer. Example. Commutative property. Example. Consider integers 3 and 4. We perform subtraction operation. 3 minus 4 equals minus 1. For minus 3 equals 1. We observe the results are different if we change the order when we execute subtraction operation. We know, for commutative property of integers, the result should be same even if we change the order when we perform the specific operation, in this case subtraction. So, we conclude, subtraction is not commutative for integers. In general, if a and b are two integers, a minus b is not equal to b minus a. Example. Associative property. Example. Consider integers 8, 4 and 2. We perform subtraction operation. 8 minus 4 minus 2. Case 1. Let us group 8 and 4, together, we get 2. Case 2. Let us group 4 and 2, together, we get 6. We observe the result of case 1 and 2 are different. But we know, for associative property of integers, the result should remain the same, regardless of how the integers are grouped. Hence, subtraction is not associative for integers. In general, if a, b and c are integers, then property of 0. When 0 is subtracted from an integer, we get the same integer. In general, if a is an integer, then a minus 0 equals a. Example. Property of 1. Subtraction of 1 from any integer gives its predecessor. Example. Consider an integer 7. 7 minus 1 equals 6. Here 6 is the predecessor of 7. This ends our topic on properties of subtraction. In the next video we will cover properties of multiplication. Welcome back. Let us continue with integers. Today we will cover properties of multiplication and properties of division. Properties of multiplication. Under properties of multiplication. Closure property. Example. Consider integers 2 and minus 2. We perform multiplication operation. 2 into minus 2 equals minus 4. In general, if a and b are two integers, then a into b will be an integer. Now, a into b equals ab. A into minus b equals minus ab equals minus a into b. Minus a into minus b equals ab. Commutative property. Example. Consider integers minus 3 and minus 7. Minus 3 into minus 7 equals 21. Minus 7 into minus 3 equals 21. We observe, the result is same even if we change the order. Hence, multiplication is commutative for integers. In general, if a and b are two integers, then a into b equals b into a. Associative property. Example. Consider integers 2, 3 and 4. We perform multiplication operation, 2 into 3 into 4. Case 1, let us group 2 and 3 together, we get. Case 2, let us group 3 and 4 together, we get. We observe, the result of case 1 and 2 are same. So, regardless of how the integers are grouped, the result is same. Hence, multiplication of integers is associative. In general, if a, b, and c are integers, then multiplicative identity. Example. consider an integer, -3. -3 into 1 equals, -3. 1 into -3 equals, -3. The product, meaning multiplication, of any integer with 1, gives the same integer. In general, if a is an integer, a into 1 equals 1 into a. Multiplicative inverse. The product of any integer and its reciprocal gives the result as 1. Example: 3 into 1 by 3 equals 1. 1 by 3 into 3 equals 1. In general, if a is an integer, a into 1 by a equals 1. Property of 0. Example: -3 into 0 equals 0. 0 into -3 equals 0. So, the product of an integer and 0 is 0. In general, if a is an integer, then a into 0 equals 0. Distributive property. Example: distributivity of multiplication over addition. 2 into 4 plus 5 equals 2 into 4 plus 2 into 5. 18 equals 18. Example: distributivity of multiplication over subtraction. 9 into -5 minus 8 equals 9 into -5 minus 9 into 8. -117 equals -117. So in general, for any integers a, b, and c, a into b plus or minus c equals ab plus or minus c. Hence, integers possess the distributive property of multiplication. Now, properties of division. Under properties of division, closure property. Closure property does not hold good for division of integers. For example, for divided by 2 equals 2, here, 2 is an integer. But 7 divided by 3 equals 7 by 3, and 7 by 3 is not an integer. Commutative property. Integers division does not follow commutative property. Example: consider integers 6 and 3. 6 divided by 3 equals 2. 3 divided by 6 equals 1 by 2. So, 6 by 3 is not equal to 3 by 6. We know, for pairs of integers, when arithmetic operation is executed, should give the same result when the order is changed. This statement must be satisfied to say division is commutative for integers. But for division, for two integers a and b, a divided by b is not equal to b divided by a. Associative property. Associative property does not hold good for the division of integers. If a, b and c are three integers, then example: consider integers 4, 2 and -2. -1 is not equal to -4. Property of 1. Any integer divided by 1 gives the same integer as the quotient. In general, if a is an integer, a divided by 1 equals a. Property of 0. When 0 is divided by an integer, the result is always 0. In general, if a is an integer, 0 divided by a equals 0. This ends our topic on integers. Welcome back. Today our topic is rational numbers. To brush up your basics, check out the videos on whole numbers, integers, and fractions in Class 6 playlist. Rational numbers. The word rational arises from the term ratio. Now, the ratio of two integers 4:5 can be written as 4:5 equals 4 by 5. So, a rational number is a number that can be expressed in the form p by q, where p and q are integers and q is not equal to 0. Thus, 4 by 5 is a rational number, here p equals 4 and q equals 5. So, why do we need rational number? Example, we can represent 750 meters above sea level as 3 by 4 kilometers. Also, we can represent 750 meters below sea level as -3 by 4 kilometers. Here we can see, -3 by 4 is neither an integer nor a fractional number. We need to extend our number system to include such numbers. So, these kind of numbers are included under rational numbers. Now, consider an integer, -3, this can be expressed as -3 by 1. Also, consider the integer 0, this can be written as 0 by 1, or 0 by 2, or 0 by 3, etc. Hence, integers are rational numbers, since it concur with the definition of rational numbers. Thus, rational number includes integers and fractions. Hence we can say rational numbers includes natural numbers, whole numbers and integers. Standard of a rational number. Example. Consider the rational numbers 3 by 5, minus 5 by 8, 2 by 7. Here, the denominators of these rational numbers are positive integers. 1 is the only common factor between the numerators and denominators. Further, the negative sign occurs in the numerator. Thus, a rational number is in standard form if its denominator is a positive integer, and the numerator and denominator have no common factor other than 1. Absolute value of a rational number is represented by p by q. The absolute value of a rational number is its positive numerical value. That is, p by q equals p by q. Minus p by q equals p by q. P by minus q equals p by q. Equivalent rational number. Consider the figure. Let us represent the center by the letter O on the number line, which ranges from 0 to 1 and 0 to minus 1. If we divide each unit length, that is 0 to 1 and 0 to minus 1, into 3 equal parts, we get. Further, if we divide each unit length, that is 0 to 1 and 0 to minus 1, into 6 equal parts, we get. We can see from the figure, point P represents 1 by 3. Point Q represents 2 by 6, which can be expressed as 1 by 3. So, we can conclude P and Q are equidistant from point O. So we say rational numbers 1 by 3 and 2 by 6 are equivalent. Thus rational numbers which are represented by the same point on a number line are called equivalent rational numbers. Let A by B and C by D be two rational numbers. If A by B equals C by D, or AD equals BC, then A by B and C by D are equivalent rational numbers. If AD is greater than BC, then A by B is greater than C by D. If AD is less than BC, then A by B is less than C by D. Example. Are rational numbers 6 by 18 and 15 by 45 equivalent? We know if A by B and C by D are equivalent, then A by B is equal to C by D, or AD equals BC. Now, for rational number 6 by 18. Let A equals 6 and B equals 18. So, A by B equals 1 by 3. For rational number 15 by 45. Let C equals 15 and D equals 45. So, C by D equals 1 by 3. Since A by B equals C by D equals 1 by 3. 6 by 18 and 15 by 45 are equivalent. Or, AD equals 6 into 45 equals 270. BC equals 18 into 15 equals 270. Since AD equals BC equals 270. 6 by 18 and 15 by 45 are equivalent. Example. Express minus 45 by 75 as a rational number with numerator 15 and denominator 15. Now, observe only the number and not the positive or negative sign. We see 45 is greater than 15, also 75 is greater than 15. So, we will use division operation. So, for numerator as 15. First, consider the numerator of minus 45 by 75, that is, minus 45. And find a number which, when divides minus 45, gives 15. So, minus 45 by x equals 15. X equals minus 45 by 15. Therefore, x equals minus 3. Now, we divide numerator and denominator by minus 3. Minus 45 by 75 equals minus 45 divided by minus 3 by 75 divided by minus 3 equals 15 by minus 25. Therefore, minus 45 by 75 equals 15 by minus 25. So, here we have expressed minus 45 by 75 as a rational number with numerator 15. For denominator as 15. First, consider the denominator of minus 45 by 75, that is, 75. And find a number which, when divides 75, gives 15. So, 75 by x equals 15. X equals 75 by 15. Therefore, x equals 5. Now, we divide numerator and denominator by 5. Minus 45 by 75 equals minus 45 divided by 5 by 75 divided by 5 equals minus 9 by 15. Therefore, minus 45 by 75 equals minus 9 by 15. So, here we have expressed minus 45 by 75 as a rational number with denominator 15. Example. Express minus 4 by 9 as a rational number with denominator 36. Here we observe, denominator of minus 4 by 9, that is, 9 is less than 36. So, we will use multiplication operation. So, find a number which, when multiplied by 9, gives 36. 9 into x equals 36. X equals 36 by 9. Therefore, x equals 4. Now, we multiply numerator and denominator by 4. Minus 4 by 9 equals minus 4 into 4 by 9 into 4. Therefore, minus 4 by 9 equals minus 16 by 36. So, here we have expressed minus 4 by 9 as a rational number with denominator 36. Comparison of rational number. Example. Which is greater, minus 4 by 9, or 16 by minus 36? To make it simpler, make the denominator common for both rational numbers. Since we are comparing rational numbers, minus 4 by 9, and 16 by minus 36. For rational number, minus 4 by 9, if we multiply denominator 9 with minus 36, we get minus 324. For rational number, 16 by minus 36, if we multiply denominator minus 36 with 9, we get minus 324. Now, we have common denominator. So, for rational number, minus 4 by 9. Multiply numerator and denominator by minus 36. Also, for rational number, 16 by minus 36. Multiply numerator and denominator by 9. Since both numerators are equal, that is, 144. Therefore, minus 4 by 9 equals 16 by minus 36. Or let a equals minus 4, b equals 9, c equals 16, d equals minus 36. We know a d equals minus 4 into minus 36 equals 144. bc equals 9 into 16 equals 144. So, a d equals bc equals 144. Therefore, minus 4 by 9 equals 16 by minus 36. Thanks for watching. In the next video we will cover addition, subtraction, multiplication, and division of rational numbers. Welcome back. Friends, let us continue with our topic on rational numbers. Addition of a rational number. Now, follow these steps to add two rational numbers. Express each rational number with the positive denominator. If the denominators of the rational numbers are the same, add their numerators and divide by common denominator. Example. If the denominators of the rational numbers are different, then express them as equivalent rational numbers with the same denominator. Then, add their numerators and divide by the common denominator of the equivalent rational number. Example. 3 by 7 plus 4 by 5 equals. Since LCM of 7 and 5 is 35. Equals 15 by 35 plus 28 by 35. Equals 43 by 35. Here, since the numerator is greater than the denominator, we will express the result in the form of mixed fraction. Equals 18 by 35. Subtraction of rational number. Let p by q and r by s be two rational numbers. So, p by q minus r by s equals p by q plus minus r by s. where minus r by s is the additive inverse of r by s. Example: subtract minus 4 by 11 from minus 6 by 7. Here, the additive inverse of minus 4 by 11 is 4 by 11. Here we add the additive inverse of minus 4 by 11 to minus 6 by 7. So, minus 6 by 7 minus 4 by 11 equals minus 6 by 7 plus 4 by 11 equals minus 66 by 77 plus 28 by 77 equals minus 38 by 77. Multiplication of rational number. If p by q and r by s be two rational numbers, p by q into r by s equals p into r by q into s equals product of numerators by product of denominators. Here, since we are looking into multiplication of rational number, so we execute multiplication operation between the two rational numbers. Division of rational number. If p by q and r by s be two rational numbers, p by q divided by r by s equals p by q into s by r, where r by s is not equal to 0. P by q divided by r by s equals p into s by q into r. Example: simplify minus 22 by 16 into 16 by 22 minus 3 by 11. Minus 22 by 16 into 16 into 1 by 22 into 1 minus 3 into 2 by 11 into 2. Since LCM of 22 and 11 is 22, that is, equals minus 22 by 16 into 16 minus 6 by 22 equals minus 5 by 8. Rational numbers between two rational numbers. Example: find rational number between 1 by 2 and 4 by 3. Here, LCM of 2 and 3 is 6. So 1 by 2 equals 1 into 3 by 2 into 3 equals 3 by 6. 4 by 3 equals 4 into 2 by 3 into 2 equals 8 by 6. It is clear that integers 4, 5, etc. lie between 3 and 8. Thus, rational numbers between 1 by 2 and 4 by 3 are 4 by 6, 5 by 6, etc. Terminating and non-terminating decimals. First, let us look into terminating. Example: consider rational number 15 by 4. 15 by 4 equals 15 divided by 4. After executing the division operation, the remainder is 0. From the above example, we see the division process comes to an end after some steps. Such types of decimals are called terminating decimals. Next, let us look into non-terminating. Example: consider rational number 1 by 3. 1 by 3 equals 1 divided by 3. Now, let us execute division operation. Here we get a remainder continually, in this case, 1. In the above case, the division process does not come to an end, it repeats itself. Such types of decimals are called non-terminating decimals. This can be either a digit repeating itself again and again, or a group of digits repeating itself again and again. The following recurring decimals can be written as 1 by 3 equals 0.333, or the line above 3 is termed as bar, we say 0.3 bar. 1 by 7 equals 0.142857 bar. Here, a bar over 3 means 3 is repeated again and again. A bar over 142857 means 142857 is repeated again and again. Now, non-terminating, non-repeating decimals cannot be converted into rational numbers. So, they are called irrational numbers. Example: value of pi is 3.14159, etc. It is non-terminating and non-repeating decimal. Square root of 3 equals 1.73205, etc. Square root of 2 equals 1.41421, etc. Now, we can draw the tree diagram for real number. Rules of terminating and non-terminating repeating decimals. Example: 1 by 2 equals 0.5. 12 by 25 equals 0.48. 1 by 3 equals 0.333, etc. equals 0.3 bar. 1 by 12 equals 0.08333 etc. equals 0.083 bar. So, from the above two examples, if a rational number is in its lowest term, and its denominator has no factor other than 2 or 5, or both, then the rational number has a terminating decimal representation. Otherwise it has a non-terminating repeating decimal representation. Conversion of a non-terminating repeating decimal into rational numbers. Example, 0.016 bar. Let x equals 0.016 bar. Here, we have 3 digits after the decimal point, out of which 2 digits are repeating. Now, we multiply equation 1 by 10, so that only the repeating decimal is left on the right side of the decimal point. Therefore, 10x equals 0.16 bar, call this equation 2. Now, from equation 2, 2 digits are repeating. So we multiply equation 2 by 100. Therefore, 1000x equals 16.16 bar, call this equation 3. Subtracting equation 2 from 3, we get x equals 8 by 495. 1.16 bar. Let x equals 1.16 bar. Here, we have 2 digits after the decimal point, out of which 1 digit is repeating, that is 6 bar. So, we multiply equation 1 by 10, so that only the repeating decimal is left on the right side of the decimal point. Therefore, 10x equals 11.6 bar, call this equation 2. Now, from equation 2, only 1 digit is repeating. So we multiply equation 2 by 10. Therefore, 100x equals 116.6 bar, call this equation 3. Subtracting equation 2 from 3, we get x equals 7 by 6. Example. Evaluate 1.5 bar plus 2.6 bar plus 3.7 bar. Here, first we convert all the non-terminating repeating decimals into rational numbers, and then execute the addition operation. For 1.5 bar, let x equals 1.5 bar, term this as equation 1. 10x equals 15.5 bar, we obtain this when we multiply equation 1 by 10. Subtracting equation 1 from 2, we get x equals 14 by 9. Similarly, therefore, 1.5 bar plus 2.6 bar plus 3.7 bar equals 14 by 9 plus 24 by 9 plus 34 by 9 equals 72 by 9 equals 8. Example. Miss Awo earns rupees 18,000 per month. She spends 1/4 of her income on groceries, 2 by 25 of the remainder on medicine, and 1/3 of the remainder on education of children. How much money is still left with her? We know Miss Awo's income equals rupees 18,000. 1/4 of Miss Awo's income equals 1 by 4 into 18,000 equals rupees 4,500. Therefore, remainder amount, that is, the amount left after deducting rupees 4,500, which she spent on groceries, from her income of rupees 18,000, equals 18,000 minus 4,500 equals rupees 13,500. 2 by 25 of the remainder amount equals 2 by 25 into 13,500 equals rupees 1,080. Remainder amount equals 13,500 minus 1,080 equals rupees 12,420. 1/3 of the remainder amount equals 1 by 3 into 12,420 equals rupees 4,140. Remainder amount equals 12,420 minus 4,140 equals rupees 8,280. Therefore, Miss Awo is left with rupees 8,280. This ends our topic on rational numbers. Welcome back. Today our topic is fractions. To brush up your basics, please check out the video on fractions in Class 6 playlist. Multiplication of fractions. Under multiplication of fractions. Multiplication of fraction by a whole number. We need a rule to multiply a fraction by a whole number. So, consider the diagram. Here, the blue section represents 1/4 of the circle. Here, the yellow section also represents 1/4 of the circle. Now, if we combine figure 1 and figure 2, we get figure 3 represents 2/4, or half of the circle. So, this can be written as 1/4 plus 1/4 equals 2/4. This can be further simplified as 2 into 1/4 equals 2/4. Here we can see 2 is a whole number, and 1/4 is a fraction. This gives us the rule to multiply a fraction by a whole number, that is, fraction into whole number equals numerator of the fraction into whole number by denominator of the fraction. Example. Solve 39/16 into 5. Here, we have mixed fraction and a whole number. So, first convert mixed fraction into improper fraction. Here we do this to make it easier to calculate. Hence, 39/16 equals 16 into 3 plus 9/16 equals 57/16. Therefore, 57/16 into 5 equals. Now, we apply the rule, multiplication of fraction by a whole number. So, 57 into 5/16 equals 285/16. Since we are getting the result as an improper fraction, 285/16, that is numerator is greater than denominator. We change it into a mixed fraction. 285/16 equals 1713/16. Now, how did we obtain this mixed fraction? 285 divided by 16. 16 into 17, we have 272. So we get the remainder as 13. We stop division operation at this point because if we divide further we will have decimal. Now we arrange as follows. Mixed fraction equals quotient, remainder by divisor. Here the quotient is 17. Remainder is 13. Divisor is 16. Multiplication of fraction by a fraction. To understand multiplication of two fractions, consider product of 1/2 into 1/4. Now, let us start with a whole. To make 1/4 of a whole, divide whole into 4 equal parts. Now, we find half of 1/4. That is, to divide 1/4 into 2 equal halves. So, 1/2 of 1/4 implies 1/2 into 1/4 equals 1 into 1 divided by 2 into 4 equals 1/8. So half of 1/4 equals 1/8. Hence, product of two fractions equals product of their numerator by product of their denominator. Example. Solve 7/1/7 into 3/1/4. So, first convert mixed fraction into improper fraction. 7/1/7 equals 50/7. 3/1/4 equals 13/4. Therefore, 50/7 into 13/4 equals 50 into 13 divided by 7 into 4 equals 325/14. Since the result is improper fraction, we change it into mixed fraction. That is, 325/14 equals 23/3/14. Multiplication of 3 or more fractions. To find the product of 3 or more fractions, first multiply two fractions and then multiply their product by the third fraction. Example. Solve 15/18 into 6/9 into 27/21. We get 5/7. So, product of fractions equals product of their numerators by product of their denominators. Multiplication of fractions as an operator of. Consider the diagram. Let 1 represent figure 1. Now divide figure 1 into 3 equal parts. Blue-colored part in figure 2 represents 1/3 of 1. Now, divide figure 2 horizontally into 2 parts. Green-colored part in figure 3 represents half of 1/3. Or, 1/2 into 1/3 equals 1/6. Also, if we compare figure 1 and 3, the green-colored part is 1/6 of 1. So, we observe, of represents multiplication. Example. In a class of 40 students, 1/5 of the total number of students like to study English. 2/5 of the total number of students like to study mathematics. and remaining students like to study science. How many students like to study English? How many students like to study mathematics? What fraction of the total number of students like to study science? Given, total number of students in the class equals 40. 1/5 of the total number of students like to study English. So, 1 by 5 of 40 equals 1 by 5 into 40 equals 8 students. 2/5 of the total number of students like to study mathematics. So, 2 by 5 of 40 equals 2 by 5 into 40 equals 16 students. Now, how to find number of students who like science? Here, there are only 3 groups of students in the class. Students who like English, students who like maths, and students who like science. Therefore, total number of students in the class should be students who like English plus students who like maths plus students who like science. So, 40 equals 8 plus 16 plus students who like science. 40 equals 24 plus students who like science. Therefore, students who like science equals 40 minus 24 equals 16. Thus, the required fraction of students who like to study science is 16 out of 40 students. Reciprocal of fraction. Reciprocal of a fraction is obtained by interchanging its numerator and denominator. Example: fraction A by B. Its reciprocal is B by A. Fraction 2 by 3. Its reciprocal is 3 by 2. 2 by 3. Its reciprocal is 3 by 8. Now, properties of reciprocal. Reciprocal of 0 does not exist. Reciprocal of 1 is 1. If a number is greater than 1, then its reciprocal is less than 1. If a number is less than 1, then its reciprocal is greater than 1. Example: the length and breadth of a rectangle are 4 1 by 5 meters and 3 2 by 3 meters. Find area of rectangle. We have length equals 21 by 5 meters. Breadth equals 11 by 3 meters. Area of rectangle equals length into breadth equals 21 by 5 into 11 by 3 equals 77 by 5 meters square. Or, area of rectangle equals 15 by 5 meters square. Example: Aman traveled 48 kilometers to see her parents. She traveled the first 18 kilometers by car, and the remaining distance by train. Find the fraction of the journey Aman traveled by car. Let total distance Aman traveled be represented by AC, 48 kilometers. And let the distance Aman traveled by car be represented by AB, 18 kilometers. Therefore, fraction of the journey Aman traveled by car equals 18 by 48 equals 3 by 8. Example: Mr. Lotha practices cricket for 1 by 2 hours every Monday, Tuesday, Wednesday. He practices cricket for 2 by 3 hours every Thursday, Friday, Saturday. He does practice on Sunday for 3 by 2 hours. How many hours does he practice in a week? Mr. Lotha, on Monday, Tuesday, Wednesday, practices cricket for 1 by 2 hours. Equals 3 by 2 hours. So, total hours for Monday, Tuesday, and Wednesday equals 3 by 2 plus 3 by 2 plus 3 by 2 equals 9 by 2 hours. Mr. Lotha, on Thursday, Friday, Saturday, practices cricket for 2 by 3 hours. Equals 7 by 3 hours. So, total hours for Thursday, Friday, and Saturday equals 7 by 3 plus 7 by 3 plus 7 by 3 equals 21 by 3 equals 7 hours. On Sunday he practices for 3 by 2 hours equals 7 by 2. From 1, 2 and 3, we get total hours in a week equals 9 by 2 plus 7 by 2 equals 30 by 2 equals 15 hours. This ends our topic on multiplication of fractions. In the next video we will cover division of fractions. Welcome back. Today our topic is division of fractions. Under division of fractions. Division of whole number by a fraction. Let us find 1 divided by 1 by 2. This means we divide a whole into a number of equal parts such that each part is half of the whole. The number of such half parts will be 1 divided by 1 by 2, that is, we will have 2 half parts. So here, how many half parts do we see? From figure we see 2 half parts. So, if we divide a whole into half, we will have 2 half parts. Also, if we multiply a whole and the 2 parts, we get 2. Thus, 1 divided by 1 by 2 equals 1 into 2 by 1. Also here we can observe, the reciprocal of 1 by 2 is 2 by 1. Similarly, 3 divided by 1 by 4 equals number of 1 by 4 parts obtained, when each of the 3 whole are divided into 1 by 4 equal parts. Equals 12. Now, we divide each of the 3 whole into 1 by 4 equal parts. So, if we divide 3 whole into 1 by 4 parts, we get 12. Also, when we multiply 3 into the 4 parts, we get 12. Thus, 3 divided by 1 by 4 equals 3 into 4 by 1. Thus, to divide a whole number by any fraction, multiply that whole number by the reciprocal of that fraction. Example. Solve 5 divided by 3 1 by 3 equals 5 divided by 10 by 3. Now, reciprocal of 10 by 3 is 3 by 10. So, 5 into 3 by 10 equals 3 by 2 equals 1 1 by 2. Division of a fraction by a whole number. Example. Solve 2 by 11 divided by 3 equals 2 by 11 into 1 by 3 equals 2 by 33. Division of a fraction by another fraction. Example. Solve 6 5 by 7 divided by 3 5 by 14 equals 47 by 7 divided by 47 by 14 equals 2. Example. By what number should we divide 4 3 by 4 to get 1 2 by 3? Now, let us write the above question in the form of arithmetic equation. Let x be the number to divide 4 3 by 4 to get 1 2 by 3. So, 4 3 by 4 divided by x equals 1 2 by 3. 19 by 4 into 1 by x equals 5 by 3. 20x equals 57. So, x equals 57 by 20. Therefore, x equals 217 by 20. Example. Miss Awo had 3 pizzas, she shared the pizzas with her friends. Each of them ate 3 by 7 of a pizza. How many friends ate the pizzas? Number of pizzas Miss Awo had equals 3. Number of pizzas each of Miss Awo friends ate equals 3 by 7. Therefore, number of friends who ate the pizzas equals 3 divided by 3 by 7. Equals 3 into 7 by 3. Equals 7. Example. Miss Seema walked 3 by 4 kilometers in 1 by 2 hours. How many distance did she cover in 1 hour? In 1 by 2 hours, Miss Seema walks equals 3 by 4 kilometers. 5 by 2 hours equals 15 by 4 kilometers. Here 5 by 2 hours can be written as 5 by 2 into 1 hour equals 15 by 4 kilometers. Therefore, 1 hour equals 15 by 4 divided by 5 by 2 kilometers. 1 hour equals 3 by 2 kilometers. So, in 1 hour, Miss Seema walks 1 by 2 kilometers. Therefore, Miss Seema walks 1 by 2 kilometers per hour. Example. Area of a rectangular plot of land is 36 by 10 meters square. If the length of the plot is 7 3 by 5, find the breadth of the plot. Given area equals 36 by 10 meters square. Length equals 7 3 by 5. We know area of rectangle equals length into breadth. 36 by 10 equals 7 3 by 5 into breadth. 361 by 10 equals 38 by 5 into breadth. Breadth equals 361 by 10 divided by 38 by 5. Breadth equals 19 by 4. Therefore, breadth of the plot equals 4 3 by 4. This ends our topic on fractions. Welcome back. Today our topic is conversion of units. Subtopic under decimals. Conversion of units. We know the standard unit of measuring length is meter. The standard unit of measuring capacity is liter. The standard unit of measuring mass is kilogram. Now, what is mass? Simple definition of mass is the quantity of matter within a given object. Again, one might ask here, what does matter mean? At the most fundamental level, matter is composed of elementary particles, known as quarks and leptons. And leptons are the elementary particles that includes electrons. Here elementary particles are the smallest known building blocks of the universe. Now, quarks combine into photons and neutrons, and along with electrons, form atoms of the elements of the periodic table, such as hydrogen, oxygen, and iron. Atoms may combine further into molecules such as water molecule, H2O. Large groups of atoms or molecules form the bulk matter of everyday life. This is the short gist of what we are hinting at when we say matter. So, why do we use unit of mass as kg? The International System of Units is based upon a set of units. Kilogram is one of the 7 base units, while gram is a derived unit, that is, 1 kilogram equals 1000 gram. Use of kg as base unit simplifies the system. Now, don't confuse between mass and weight. As we have seen, mass is the measurement of the quantity of matter, and weight is the measurement of the Earth's gravitational pull on an object. That is, weight is combination of mass and gravity. Weight equals mass into gravity. Next is the word capacity. In mathematics, capacity is defined as the maximum quantity a container can hold when full. So, now that we have cleared the overview of the words or terms that we have come across here, let us continue with our topic at hand. We know 1 kilogram equals 1000 grams. Therefore, 1 gram can be written as 1 by 1000 kg. Also, 1 gram equals 1000 milligrams. 1 liter equals 1000 milliliters. So, 1 milliliter can be written as 1 by 1000 liter. 1 kiloliter equals 1000 liters. 1 by 1000 kiloliter equals 1 liter. 1 kilometer equals 1000 meters. 1 meter can be written as 1 by 1000 kilometer. 1 meter equals 100 centimeters. 1 by 100 meter equals 1 centimeter. 1 meter equals 1000 millimeters. 1 by 1000 meter equals 1 millimeter. Word problem. Example. Miss Angami distributed 1.5 liters of milk equally among 5 students. How many milliliters of milk did one student get? Given, total number of students equals 5. Total quantity of milk equals 1.5 liters. Now, first let us convert liter into milliliter. So, total quantity of milk equals 1.5 into 1000 milliliters equals 1500 milliliters. Since milk was distributed equally among 5 students, milk distributed among 5 students equals total quantity of milk available equals 1500 milliliters. For one student equals 1500 by 5 milliliters equals 300 milliliters. Therefore, one student will get 300 milliliters of milk. Or, let X represent a single student. Now, milk distributed among 5 students equals 1500 milliliters. So, 5x equals 1500 milliliters. Therefore X equals 300 milliliters. Example. If 1 inch is equal to 2.54 centimeters, then how many inches will 60.96 centimeters make? Given, 1 inch equals 2.54 centimeters. Now, 2.54 centimeters can be expressed as 2.54 into 1 centimeter. Therefore, 1 centimeter equals 1 by 2.54 inch. So, 60.96 centimeters equals 60.96 into 1 by 2.54 inch. Therefore, 60.96 centimeters equals 24 inch. Example. Product of two numbers is 18.576, if one of them is 5.4, find the other. Given, product of two numbers is 18.576. Let x and y be the two numbers. So, x into y equals 18.576. Also, one of the number is 5.4. So, either x or y can be equal to 5.4. Let us assume x equals 5.4. Therefore, 5.4 into y equals 18.576. Y equals 3.44. Therefore, the other number is 3.44. Example. A car covers a distance 198.22 kilometers in 4.4 hours. Find the distance covered in 1 hour. Given, a car covers a distance 198.22 kilometers in 4.4 hours. 198.22 kilometers equals 4.4 hours. So, 198.22 by 4.4 equals 1 hour. Therefore, in 1 hour, the car covers 45.05 kilometers. Example. Miss Awo have two gold rings weighing 7.534 grams and 5,300 milligrams. Identify the heavier ring after converting the rings into the same unit. We have 7.534 grams and 5,300 milligrams equals 5,300 into 1 by 1,000 grams equals 5.3 grams. So Miss Awo have two gold rings weighing 7.534 grams and 5.3 grams. Therefore, the gold ring weighing 7.534 grams is heavier. This ends our topic on decimals. Welcome back. Today our topic is simple linear equations. Now, let us first understand, what is an equation? An equation is a mathematical statement with an equal to symbol between two expressions that have equal value. Example, 2x plus 5 equals 10. Here, the equality sign indicates that the value of the expression on the LHS is equal to the value of the expression on the RHS. That is, LHS is equal to RHS. Now, if there is other sign other than equality sign between LHS and RHS, it is not an equation. Example. This is not an equation, it simply says the value of 2x plus 4 is greater than 8. This also is not an equation, it simply says the value of 2x plus 4 is lesser than 8. Balancing of an equation. To balance an equation, there are 4 rules which must be followed. Rule 1, any number added to one side must be added to the other side. Example, x minus 2 equals 5. Now, if we add 2 on both sides, we can easily isolate x and find its value. So, x minus 2 plus 2 equals 5 plus 2. Therefore, x equals 7. Rule 2, any number subtracted from one side of an equation must be subtracted from the other side too. Example, x plus 2 equals 5. Now, if we subtract 2 from both sides, we can easily isolate x and find its value. So, x plus 2 minus 2 equals 5 minus 2. Therefore, x equals 3. Rule 3, we can multiply both sides of an equation by the same non-zero number. Example, x by 2 equals 4. Now, if we multiply both sides by 2, we can easily isolate x and find its value. So, x by 2 into 2 equals 4 into 2. Therefore, x equals 8. Rule 4, we can divide both sides of an equation by the same non-zero number. Example, 4x equals 48. Now, if we divide both sides by 4, we can easily isolate x and find its value. So, 4x divided by 4 equals 48 divided by 4. Therefore, x equals 12. So, when solving for an unknown variable, balancing ensures that the variable is isolated, while the equation remains true. Now, root of an equation. In mathematics, the root of an equation refers to the value or values of the variable that make the equation true, typically resulting in a zero value when substituted back into the equation. An equation can have a single root, multiple roots, or no roots at all. Example, solve 3x plus 7 equals 22. Let's call 3x plus 7 equals 22 as equation 1. Now, we try to isolate x from the equation. First, let's subtract 7 from both sides of equation 1. 3x plus 7 minus 7 equals 22 minus 7. We get 3x equals 15. Let's call this as equation 2. Divide both sides of equation 2 by 3. 3x divided by 3 equals 15 divided by 3. Therefore, x equals 5. If we substitute the value of x in equation 1, we get 22 equals 22. Therefore, value of variable x equals 5 makes the equation true. Hence, 5 is the root of the equation. Solution of a linear equation. Trial and error method. Here, we substitute various values for an unknown value in an equation, and find the particular value, for which the value of the LHS becomes equal to the value of the RHS in the equation. Example, solve 7 minus x equals 3. Consider the table. In the first column we have value of x. In the second column we have LHS of the given equation, 7 minus x. In the third column we have RHS of the equation, 3. And in the fourth column we have conclusion. Now, if we substitute the value of x as 1, we get LHS as 7 minus 1 equals 6. RHS does not have any variable, so the value remains the same, that is 3. Conclusion is, LHS is not equal to RHS, since 6 is not equal to 3. We execute the same process sequentially, substituting for the value of x. Now, for the value of x equals to 4, LHS equals RHS. Therefore, x equals to 4 is the solution of the equation. Systematic method. As we have seen, the trial and error method becomes lengthy and inconvenient in solving an equation. So we use systematic method to find the solution. Example, solve 2 into m plus 6 equals 3 into m minus 10. So, 2m plus 12 equals 3m minus 30, let's call this as equation 1. Now, we transpose minus 30 to LHS and 2m to RHS. Remember, changing sides is called transposing. While transposing a number, we change its sign. So, 12 plus 30 equals 3m minus 2m. m equals 42. Now, let us check. Substituting the value of m equals 42 in LHS and RHS of equation 1, we get LHS equals 2m plus 12 equals 84 plus 12 equals 96. RHS equals 3m minus 30 equals 126 minus 30 equals 96. Therefore, LHS equals RHS. Example, solve the equation and check. X minus 5 by 7 minus 8 equals 2x plus 4 by 5. First, let us simplify this equation. So we have 5x minus 305 equals 14x plus 28. Let's call this as equation 1. Transposing 5x to RHS and 28 to LHS. We get minus 333 equals 9x. X equals minus 37. Now, let us check. Substituting the value of x equals minus 37 in LHS and RHS of equation 1, we get LHS equals 5x minus 305 equals minus 185 minus 305 equals minus 490. RHS equals 14x plus 28 equals minus 518 plus 28 equals minus 490. Therefore, LHS equals RHS. Simple application of a linear equation. The following steps should be taken to solve a word problem of linear equation. Read the problem carefully, and note down what is given and what is required. Analyze and understand the relationship between different quantities given. Represent the required quantity by a variable, say x, y, z, etc. State the relationship as an algebraic equation. Solve the equation for the unknown quantity. Example. In a family, the consumption of cereals and vegetables is in the ratio 5:2. If the total quantity is 35 kilograms, find the consumption of each. Step 1. Given ratio of consumption of cereals and vegetables equals 5:2. Total quantity of cereals and vegetables equals 35 kilograms. We have to find consumption of cereals and consumption of vegetables. Step 2. Let us represent consumption of cereals by variable x and consumption of vegetables by variable y. Step 3. We have x by y equals 5/2. Let's call this equation 1. Also, total quantity of cereals and vegetables, that is, x plus y equals 35 kilograms, let's call this as equation 2. From equation 1, x by y equals 5/2. X equals 5y/2. Now, substituting value of x in equation 2, we get 5y plus 2y equals 2 into 35. Y equals 10 kilograms. So, x equals 5y/2 equals 5 into 10/2. X equals 25 kilograms. Therefore, consumption of cereals equals x equals 25 kilograms. Consumption of vegetables equals y equals 10 kilograms. Divide 38 in two parts, such that one part is 18 more than the other. Find the values of the two parts. Given, divide 38 in two parts. One part is 18 more than the other. Let us represent first part by variable x. Second part by variable y. Now, x plus y equals 38. Let's call this as equation 1. Also, one part is 18 more than the other part. Let's call this as equation 2. Here you can assume one part as either x or y. We assume it as y. Substituting the value of y in equation 1. X plus 18 equals 38. X equals 10. Also from equation 2, y equals x plus 18. Therefore, y equals 28. A number is 3 times another number. When the larger number is subtracted from 100, the result is 30 more than the smaller number subtracted from 50. Find the numbers. It is clear that there are two numbers involved here. Let us represent first number with variable x and second number with variable y. Given is x equals 3y, let's call this as equation 1. Here, we can observe x is the larger number compared to y. And larger number is subtracted from 100. That is, 100 minus x. And result is 30 more than the smaller number subtracted from 50. That is, 30 plus 50 minus y. Therefore, 100 minus x equals 30 plus 50 minus y. From equation 1, x equals 3y. So, 100 minus 3y equals 30 plus 50 minus y. Transposing, we get minus 2y equals minus 20. Y equals 10. And x equals 3y. Therefore, x equals 30. Miss Angami is 5 years old. Her father's age is 31 years. After how many years will her father's age be 3 times of her age? Given, Miss Angami's age equals 5 years. Her father's age equals 31 years. Now, after x years, father's age will be 31 plus x. After x years, Miss Angami's age will be 5 plus x. Given, after x years, father's age equals 3 times Miss Angami's age. So, 31 plus x equals 3 into 5 plus x. 2x equals 16. X equals 8 years. Therefore, after x equals 8 years, father's age will be 3 times Miss Angami's age. This ends our topic on simple linear equations. Welcome back. Today our topic is the triangle and its properties. A triangle is a simple closed curve made of 3 line segments. It has 3 vertices, 3 sides, and 3 angles. Now, sides opposite to vertex A is BC, vertex B is 8C, vertex C is 8B. Triangles are based on Sides. Scalene, isosceles, and equilateral triangles. Based on angles. Acute angled, obtuse angled, and right-angled triangles. Median of a triangle. Is a line segment connecting a vertex to the midpoint of the opposite side. Example. Here, line segment AD connects vertex A to the midpoint of BC. Is called the median of the triangle. Altitude of a triangle. Is a line segment drawn from a vertex perpendicular to the opposite side. It is commonly referred to as the height of a triangle and is denoted by the letter H. Now, 3 altitudes can be drawn in every triangle from each of the vertices. Example. Here, we can observe that all the 3 altitudes of the triangle meet at a point. This point is known as orthocenter. Exterior angle of a triangle and its properties. Theorem. An exterior angle of a triangle is equal to the sum of its interior angles. Consider a triangle ABC. Let 1, 2, and 3 be the angles formed. Extend side BC to D. Now, an exterior angle ACD is formed. Draw a line CE parallel to AB. X and Y are the angles formed. So, angle ACD can be written as angle X plus angle Y. We have to show angle ACD is equal to angle CAB plus angle ABC. Here, angle CAB equals angle 1 and angle ABC equals angle 2. We can write angle 1 equals angle X. Reason is, line segment BA is parallel to CE and AC is the transversal. Therefore, alternate angles should be equal. Angle 2 equals angle Y. Since line segment BA is parallel to CE and BD is the transversal. Therefore, corresponding angles should be equal. Now, angle 1 plus angle 2 can be written as angle X plus angle Y. Also, angle ACD equals angle X plus angle Y from the figure. Therefore, from the above steps, angle ACD equals angle 1 plus angle 2. Or angle ACD equals angle CAB plus angle ABC. The above relationship between an exterior angle and its 2 interior opposite angles is referred to as the exterior angle property of a triangle. Angle sum property of a triangle. Theorem. The sum of the angle of a triangle is 180 degrees. Consider a triangle ABC. Let 1, 2, and 3 be the angles formed. Extend BC to D. Now, an exterior angle ACD is formed. Draw a line CE parallel to AB. X and Y are the angles formed. So, angle ACD equals angle X plus angle Y. We have to show angle CAB plus angle ABC plus angle BCA equals 180 degrees. Here, angle CAB equals angle 1, angle ABC equals angle 2, and angle BCA equals angle 3. So, angle 1 equals angle X. Reason is, line segment BA is parallel to CE, and as C is the transversal. Therefore, alternate angles should be equal. Also, angle 2 equals angle Y. Since line segment BA is parallel to CE and BD is the transversal. Therefore, corresponding angles should be equal. So, angle 1 plus angle 2 can be written as angle X plus angle Y. Now, angle 1 plus angle 2 plus angle 3 equals angle X plus angle Y plus angle 3. That is, adding angle 3 on both sides. Now, we know angle ACD equals angle X plus angle Y. So, angle 1 plus angle 2 plus angle 3 equals angle ACD plus angle 3. If we observe the figure, here, angle ACD and angle 3 form a linear pair. So, angle ACD plus angle 3 equals 180 degrees. Therefore, angle 1 plus angle 2 plus angle 3 equals 180 degrees. Or, angle CAB plus angle ABC plus angle BCA equals 180 degrees. Example. Find the value of x and y. From the figure, we know angle y plus angle x equals 180 degrees, that is, angle some property. So, angle y plus 2 times angle x equals 180 degrees. Now, angle y equals 75 degrees, that is, from the figure, vertically opposite angles. Substituting the value of angle y in 1, we get angle x equals 52.5 degrees. Example. Find angle P. We have to find angle P, that is, angular PQ. We know 120 degrees plus angle PQR equals 180 degrees, that is, linear pair. So, angle PQR equals 60 degrees. Also, 110 degrees plus angle QRP equals 180 degrees, again reason is linear pair. So, angle QRP equals 70 degrees. Also, angular PQ plus angle PQR plus angle QRP equals 180 degrees, from angle some property. Therefore, angular PQ equals 50 degrees. Example. The exterior angle, angle ACD, of triangle ABC, is 110 degrees, and angle A and angle B are in the ratio 7:4. Find all the angles of triangle ABC. Given, angle ACD equals 110 degrees. Let angle A equals 7x and angle B equals 4x. We know angle ACD equals angle A plus angle B, reason is exterior angle property. 110 degrees equals 7x plus 4x. So, x equals 10 degrees. Therefore, angle A equals 70 degrees. Angle B equals 40 degrees. Now, angle A plus angle B plus angle C equals 180 degrees, reason is angle some property. So, angle C equals 70 degrees. Example. Find x, y, and z. First, consider triangle DCE. Here, angle x equals 30 degrees plus 110 degrees, reason is exterior angle property. Therefore, angle x equals 140 degrees. Now, consider triangle ABC. Here, angle y plus angle z equals 180 degrees, reason is linear pair. Now, angle ACB equals angle DCE, reason is vertically opposite angles. So, angle ACB equals 30 degrees. And 30 degrees plus angle y plus 30 degrees equals 180 degrees, reason is angle some property. Therefore, angle y equals 120 degrees. And angle z equals 60 degrees. Sum of two sides of a triangle. Here, the sum of the length of two sides of a triangle is greater than its third side. That is, AB plus BC is greater than CA. Or, BC plus CA is greater than AB. Or, CA plus AB is greater than BC. Right-angled triangle and Pythagoras property. Pythagoras' theorem is named after the Greek philosopher Pythagoras, born around 570 BC. The theorem explains the relationship between the three sides of a right-angled triangle. Here relationship means the way in which two or more things are connected. Pythagoras' theorem states that if a triangle is a right-angled triangle, then the square of the hypotenuse is equal to the sum of the square of the other two sides. That is, BC square equals AB square plus SC square. Example. Mr. Lotha walks 24 kilometers towards east and then 7 kilometers towards north. Find the distance between the starting point and the final position. Let A be the starting point. From point A, Mr. Lotha walks 24 kilometers towards east. Let's call this location as point B. Now, from point B, Mr. Lotha walks 7 kilometers towards north. Let's call this position as point C, which is the final position. We have to find the distance between the starting point and the final position, that is, AC. We know AC square equals AB square plus BC square. AC square equals 24 kilometers square plus 7 kilometers square. SC equals square root of 625 kilometers square. Therefore, 8C equals 25 kilometers. A tree is broken at a height 5 meters from the ground, and its top touches the ground at a distance of 12 meters from the base of the tree. Find the original height of the tree. Original height of tree equals AB plus AC. Now, 8C square equals AB square plus BC square. AC equals square root of 169 meters square. SC equals 13 meters. Therefore, original height of tree equals 5 meters plus 13 meters equals 18 meters. This ends our topic on the triangle and its properties. Welcome back. Today our topic is lines and angles. To brush up your basics, please check out the video on basic geometry in our Class 6 playlist. Complementary angles are two angles whose sum is 90 degrees. We know a right angle is 90 degrees angle. And complementary angles are related to this concept because their sum forms a right angle. Example. Here, figure 1 and 2 are complementary angles because 30 degrees plus 60 degrees equals 90 degrees. Since 90 degrees is the measure for a right angle. Here, 30 degrees angle is the complement of the 60 degrees angle, and vice versa, because together, they form a right angle. Here, complement suggests a strong relationship where two things fit together well, or complete each other. So, we may say, complementary angles complete a right angle. Supplementary angles are two angles whose sum is 180 degrees. Here supplement means adding to something, often to enhance it or expand it. We know a straight line is 180 degrees angle. And supplementary angles are related to this concept because their sum forms a straight line angle. Example. Here, figure 1 and 2 are supplementary angles because 60 degrees plus 120 degrees equals 180 degrees. So, we may say, supplementary angles complete a straight line. Easy way to not get confused between complementary angles and supplementary angles is complementary starts with the letter C and supplementary starts with the letter S. Here, letter C comes first in the alphabetical order. Also, number 90 comes first in the numerical order. So, assign letter C with number 90 and letter S with number 180. Adjacent angles are two angles that shares a common vertex and a common side, but do not overlap or intersect. Example. Here, angle AOB and angle BOC are adjacent angles. Since both angles have common vertex, that is, O, common side, that is, OB, angle AOB and angle BOC do not overlap or intersect. Now, angle AOB and angle AOC are not adjacent angles. Since angle AOB and angle AOC overlap or intersect each other. Linear pair. When two lines intersect each other at a single point, linear pairs of angles are formed. If the angles so formed are adjacent to each other after the intersection of the two lines, the angles are said to be linear. If two angles form a linear pair, the angles are supplementary, whose measures add up to 180 degrees. Hence, a linear pair of angles always add up to 180 degrees. Properties of linear pair angles. The sum of two angles in a linear pair is always 180 degrees. All linear pairs of angles are adjacent angles, but all adjacent angles are not linear pairs. Linear pair of angles shares a common vertex and a common arm between them. They always form a straight line. They can be considered as two parts of a 180 degrees angles or a straight line, vertically opposite angles. When two lines intersect each other at a point, the two pairs of angles, formed without any common arm, are called vertically opposite angles. Example. Now, line AB and CD intersects at O. We can observe it forms four angles: angle AOC, angle COB, angle BOD, and angle AOD. Here, angle AOC and angle BOD have no common arm. Hence, angle AOC and angle BOD are vertically opposite angles. Similarly, angle COB and angle AOD are vertically opposite angles. Now, let us prove vertically opposite angles are always equal to each other. Consider two lines, PQ and RS, intersects each other at point O. We have to prove angle POR equals angle SOQ, that is, angle 1 equals angle 3. And angle POS equals angle ROQ, that is, angle 2 equals angle 4. We know, from properties of linear pair angles, angle 1 plus angle 2 equals 180 degrees. Angle 2 plus angle 3 equals 180 degrees. Angle 3 plus angle 4 equals 180 degrees. And angle 1 plus angle 4 equals 180 degrees. From 1 and 2. Angle 1 plus angle 2 equals angle 2 plus angle 3. Therefore, angle 1 equals angle 3, hence, angle POR equals angle SOQ. From 2 and 3. Angle 2 plus angle 3 equals angle 3 plus angle 4. Therefore, angle 2 equals angle 4, hence, angle POS equals angle ROQ. Example. If one of the angle in a pair of supplementary angles is acute, then what kind of angle is the other? We know, acute angle, are angle that measures less than 90 degrees. Supplementary angle, are two angles whose sum is 180 degrees. Since acute angle is less than 90 degrees, the other angle must be greater than 90 degrees. To reach a total of 180 degrees. We know, obtuse angle, are angle that measures greater than 90 degrees. So here, we can conclude, supplementary angles equals acute angle plus obtuse angle. Therefore, the other angle is obtuse. Transversal. A line which intersects two or more given lines at different points is called a transversal. Here, line L is the transversal to line M and N. Since line L intersects line M and N at different point A and B. Angles formed by a transversal to two lines. Here we can observe, angle 1, 2, 7, and 8 lies outside line M and N. And angle 4, 3, 5, and 6 lies between line M and N. So, exterior angles. Angle 1, 2, 7, and 8 are lying outside line M and N and are called exterior angles. Interior angles. Angle 4, 3, 5, and 6 are lying between line M and N and are called interior angles. Corresponding angles are the angles on the same side of transversal, one of which is an exterior and the other is an interior. And both of them do not form a linear pair. So, angle 1 and 5, angle 4 and 8, angle 2 and 6, and angle 3 and 7 are corresponding angles. Note, here, angle 6 and 7 are not corresponding angles, because angle 6 and 7 together form a linear pair. Alternate angles. The angles which are on the opposite side of a transversal and do not form a linear pair are called alternate angles. This figure represents alternate exterior angles. Also do not form a linear pair. And this figure represents alternate interior angles. Also do not form a linear pair. Angles formed by a transversal to parallel lines. Corresponding angles. Here, angle 1 and 5, angle 4 and 8, angle 2 and 6, angle 3 and 7 are corresponding angles. Also, if the transversal intersects two parallel lines, then, the pairs of corresponding angles are equal. That is, angle 1 equals angle 5, angle 4 equals angle 8, angle 2 equals angle 6, and angle 3 equals angle 7. Alternate interior angles. Angle 4 and 6, and angle 3 and 5, are the alternate interior angles. And if the transversal intersects two parallel lines, then, alternate interior angles are equal. That is, angle 4 equals angle 6, and angle 3 equals angle 5. Alternate exterior angles.
Angle 1 and 7, and angle 2 and 8, are the alternate exterior angles. And if the transversal intersects two parallel lines, then alternate exterior angles are equal. That is, angle 1 equals angle 7, and angle 2 equals angle 8.
Interior angles on the same side of transversal
are angle 3 and 6, and angle 4 and 5. Also called as co-interior angles. In case of co-interior angles, angle 3 plus angle 6 will be equal to 180 degrees. And angle 4 plus angle 5 will be equal to 180 degrees.
Example: L is parallel to P, and M is a transversal. Find the value of X, Y, and Z.
We know, for angles formed by a transversal to parallel lines, alternate angles are equal, that is, 110 degrees equals angle Y. Also, corresponding angles are equal, that is, angle Z equals angle Y. Also, angle X plus angle Y equals 180 degrees since linear pair.
So, angle X equals 180 minus 110.
Therefore, angle X equals 70 degrees. Angle Y equals 110 degrees.
Angle Z equals 110 degrees. Example: in the given figure, the arm of two angles are parallel, and angle ABC equals 65 degrees. Find angle DEF.
Given, angle ABC equals 65 degrees.
Case 1. Assume AB and DE as the parallel arms. So, BC is the transversal.
For angles formed by a transversal to parallel lines, corresponding angles are equal, that is, angle ABC equals angle DOC. So, angle DOC equals 65 degrees.
Case 2. Now assume BC and EF as the parallel arms. So, DE is the transversal in this case.
For angles formed by a transversal to parallel lines, corresponding angles are equal, that is, angle DOC equals angle DEF. Therefore, angle DEF equals 65 degrees.
Example:
in the given figure, L is parallel to M, and P is a transversal.
Find the value of X.
We know, for angles formed by a transversal to parallel lines,
interior angles on the same side of transversal is
X plus 35 degrees equals 180 degrees.
2X plus 35 degrees equals 180 degrees.
Therefore, angle X equals 72.5 degrees.
This ends our topic on lines and angles. Welcome back.
Today our topic is perimeter and area.
First is square. Here, ABCD is a square of side A units. We know perimeter of square equals 4A. And area of square equals a square. Rectangle. Here, ABCD is a rectangle of length L units and breadth B units.
We know perimeter of rectangle equals 2 into length plus breadth. And area of rectangle equals length into breadth.
Perimeter of triangle.
Consider triangle ABC with sides A, B, and C units. So, perimeter of triangle equals A plus B plus C.
Area of right isosceles triangle. Here, since the term is right isosceles triangle,
we know the triangle should have a 90 degrees angle and two equal sides.
So, we can achieve this by consider a square ABCD. Now, diagonal AC divides it into two congruent right isosceles triangles. Triangle ABC and triangle ADC.
So, from figure, area of triangle ABC plus area of triangle ADC equals area of square ABCD. Therefore, area of triangle ABC equals 1 by 2, A square. Area of right-angled triangle. Here, since the term is right-angled triangle, we know that one angle should be 90 degrees.
But we don't have information about the dimension of the sides.
So, let us consider a rectangle, ABCD, with length and breadth as L and B units respectively. So, diagonal, AC, divides it into two congruent right-angled triangles. So, from figure, area of triangle ABC plus area of triangle ADC equals area of rectangle ABCD. Therefore, area of triangle ABC equals 1 by 2 into length into breadth.
Area of triangle. Consider a triangle, ABCD, and AB as B units.
A perpendicular, CD, is drawn such that it divides the base into two parts, AD and BD.
And let CD be H units.
Here, from figure, x plus y equals b. Area of triangle ABC equals area of right-angled triangle ADC plus area of right-angled triangle BDC. Therefore, area of triangle ABC equals 1 by 2 into base into height.
Area of parallelogram. Consider a parallelogram, ABCD, with its base as B. Diagonal, BD, divides it into two triangles, triangle ABD, and triangle BCD.
So, from figure, DE is perpendicular to AB, and BF is perpendicular to CD.
Now, since AB is parallel to DC, DE equals BF. And AB equals DC equals B units.
Area of parallelogram ABCD equals area of triangle ABD plus area of triangle BCD. Therefore, area of parallelogram ABCD equals base into height.
Example.
A wire is in the shape of a rectangle. Its length is 40 centimeters, and breadth is 22 centimeters.
If the wire is rebent in the shape of square, what will be the measure of each side? Also, find which shape enclosed more area.
Given, a wire is in the shape of a rectangle.
And same wire is rebent in the shape of square.
So, perimeter of rectangle equals perimeter of square. Or, 2 into length plus breadth equals 4a. A equals 31 centimeters. Now, area of rectangle equals length into breadth
equals 880 centimeters square.
Area of square equals side square
equals 961 centimeters square.
Therefore, measure of each side of square equals 31 centimeters.
And square shape enclose more area. Example. A veranda of width 4.5 meters is constructed around a room outside it.
If the dimensions of the room are 18.5 by 14 meters, find the following.
Area of the veranda.
The cost of paving tiles in the veranda at the rate of 20 rupees per meter square.
Let B represent the room.
Length of B equals 18.5 meters. Breadth of B equals 14 meters. And let A represent the veranda and room together. Length of A equals 27.5 meters. Breadth of A equals 23 meters.
Now, area of veranda equals area of A minus area of B.
Therefore, area of veranda equals 373.5 meters square. Now, given, cost of paving tiles for 1 meter square equals 20 rupees. So, cost of paving tiles for 373.5 meters square equals 373.5 into 20 rupees
equals rupees 7,470. Circumference of circle.
So, line segment joining the center of a circle to any point on the circle is called radius. And a line segment passing through the center of a circle with its endpoints lying on the circle is called diameter of the circle.
So, DC equals diameter.
Also, from figure, DC equals OD plus OC.
So, diameter equals 2r.
The perimeter of a circle is called its circumference, and is denoted by C. Now, if we divide circumference by the diameter,
C by D equals 2, constant.
Here, the value of this constant lies between 3.1 and 3.2. Also, this constant is represented by the symbol pi. Approximate value of pi is 22 by 7, or 3.14. And value of pi up to 5 decimal place is 3.14285. So, circumference divided by diameter equals 2 pi. Therefore, circumference of circle equals pi into diameter. Or, circumference of circle equals 2 into pi into radius. Area of circle. Draw a circle and shade 1/2 of the circle. Divide the circle into 8 parts. Arrange the separate as shown in figure, which is roughly a rectangle, as we can see from the figure. The white portion of the circle is half of the circumference, and blue portion of the circle is the other half of the circumference. So, here length of the rectangle equals half of the circumference of the circle, equals 1/2 into 2 pi r, equals pi r. Breadth of the rectangle equals radius of the circle equals r. So, area of circle equals area of rectangle equals length into breadth. Therefore, area of circle equals pi r square. The inner and outer circumference of a circular racing track are 264 centimeters and 352 centimeters respectively. Find the width of the racing track. Given, circumference of outer track equals 352 centimeters. Let r equals radius of outer track. Circumference of inner track equals 264 centimeters. Let r equals radius of inner track. Now, width of the racing track equals radius of outer minus radius of inner track. Circumference of outer track equals 2 pi r. Radius of outer track equals 56 centimeters. Circumference of inner track equals 2 pi r. Radius of inner track equals 42 centimeters. Therefore, width of racing track equals 14 centimeters. Example. How many times a wheel of radius 28 centimeters must rotate to go 352 meters? Take value of pi equals 22/7. Given, r equals 28 centimeters. Pi equals 22/7. Circumference of wheel equals 2 pi r. Equals 176 centimeters. Here, let the distance between A and B equals 352 meters. Equals 352 into 100 centimeters. So, number of times the wheel must rotate equals distance between A and B divided by circumference of wheel. Equals 200 times. This ends our topic on perimeter and area. Welcome back. Today our topic is algebraic expressions. Now first of all, what is algebra? Algebra is a branch of mathematics in which arithmetical operations and formal manipulations are applied to abstract symbols, rather than specific numbers. Here, abstract symbols, or simply symbols, are letters like X, Y, Z, P, or Q, etc. Abstract means something existing in thoughts, or an idea, but not having a physical or concrete existence. The abstract symbols or symbols do not have any fixed values, and are called variables. Simple example is, in our daily life, we often see certain values that keep on changing. Example, petrol price and petrol usage. Say, trying to figure out how much it will cost to fill your petrol tank, and how far you will be able to drive before you need to fill up again. This do not have any fixed value. There is a constant need to represent these changing values. Here in algebra, these values are often represented with symbols such as X, Y, Z, P, or Q, etc., and these symbols are called variables. These changing values are represented with symbols, and these symbols are called variables. Further, these symbols are manipulated through various arithmetic operations of addition, subtraction, multiplication, and division, with the objective to find the values. Here manipulate means to handle or control a tool, mechanism, information, etc., in a skillful manner. Example of algebraic equation. 2x plus 4 equals 28. Here, x is the variable. 4 and 28 are constant, since 4 and 28 are fixed quantities and cannot change, hence called constant.
2 is the coefficient. Now, what is coefficient?
A coefficient refers to a number, or quantity, placed with a variable.
It is usually an integer that is multiplied by the variable and written next to it.
Also, variables which do not have a number with them are assumed to be having 1 as the coefficient.
Example x squared plus 3, so here coefficient of x squared is 1. 2x squared plus 4, here coefficient of x squared is 2. We know algebraic equations are two algebraic expressions that are joined together using equal to sign. Example of algebraic equation: 2x plus 4 equals to 28. Example of algebraic expression: 2x plus 4. How are algebraic expressions formed?
We combine variables and constants to make algebraic expressions.
Now, how do we combine variables and constants?
We use arithmetic operations such as addition, subtraction, multiplication, and division to combine variables and constants.
Example: 2x plus 4. X squared plus 3.
We can also obtain expressions by combining variables with themselves or with other variables. Example: combining variables with themselves.
X squared, 2y squared.
Combining variables with other variables.
xy, 2xy plus 7. Terms of an expression. Terms can be single numbers. That is constants such as 1, 2, 3, etc. Variables. That is x, y, z, p, or q, etc.
Or the product of a number and variable.
That is 2x squared, 2xy, etc.
Several parts of an algebraic expression, separated by positive or negative signs, are called the terms of an expression.
Example: 3x plus 4. Here, we have two terms. Let's say 3x as term 1 and 4 as term 2. Now, factors of a term. Consider the expression for x squared minus 2xy. Here, we have two terms for x squared and minus 2xy. Term 4x squared is a product of 4x and x. So we say 4x and x are the factors of the term 4x squared. Similarly, for term minus 2xy. Minus 2x and y are the factors of the term minus 2xy. To make the distinction of expression, terms, and factors more clear, consider the tree diagram. For x squared minus 2xy is an algebraic expression. And 4x squared and minus 2xy are the terms of the expression. For x and x are the factors of the term 4x squared. And minus 2x and y are the factors of the term minus 2xy. Types of algebraic expressions. Monomial. An algebraic expression that contains one term is called a monomial. Example: 5x minus 7y, 2xy. Binomial. An algebraic expression that contains two terms is called a binomial. Example: x plus y, 2x plus 1, p squared minus q squared, 2 minus 3xy. Trinomial. An algebraic expression that contains three terms is called a trinomial. Example: x squared plus 3x plus 5, x cubed plus x squared minus x. Polynomial. An algebraic expression having one or more than one term are called polynomial, provided the power of its variables are non-negative integers. Example: 2x squared is a polynomial. But 2x raised to the power minus 2 is not a polynomial, since the exponent is negative integer. A polynomial comprises of constants and variables. But we cannot perform division operation by a variable in polynomial. Example: y plus 2 is a polynomial. But 1 divided by y plus 2 is not a polynomial. Since division operation cannot be performed by a variable in a polynomial, here variable is y. The exponent of its variables cannot be a fraction. Example: 2x is a polynomial. But square root of 2x equals 2x raised to the power 1 by 2 is not a polynomial. Here, we should not confuse between algebraic expression and polynomial. Since all polynomials are algebraic expression, but all algebraic expressions are not polynomials. Example: 3x squared plus 5 is an algebraic expression and is also a polynomial. Square root of 1 minus x2 divided by 1 plus x squared is an algebraic expression, but is not a polynomial. Degree of an algebraic expression. The degree of an algebraic expression depends upon the power of variables present in it. An algebraic expression can be in one variable, two variables, or more. Consider one variable, x. Example: 5x cubed plus 6x plus 8. Here we have three terms, 5x cubed, 6x, and 8. Term 5x cubed. Power of variable, x, is 3. So, here degree of term 5x cubed is 3. Term 6x, power of variable, x, is 1. Here degree of term 6x is 1. Term 8 has no variable. Hence degree of term 8 is 0. Since we know x raised to the power 0 is equal to 1, so 8x raised to the power 0 is equal to 8 into 1 equals 8. Now, highest power of the expression, 5x cubed plus 6x plus 8, is 3. Hence, the degree of the algebraic expression, 5x cubed plus 6x plus 8, is 3. So we can conclude, the degree of an algebraic expression is the highest power of variable in the expression. Consider two variables, x and y. Example: x cubed y squared plus 3x y squared plus 5x y plus 7. Here we have four terms, x cubed y squared, 3x y squared, 5x y, and 7. Term x cubed y squared. Here we have two variables, x and y. Now, when the variables are multiplied, the powers are added to decide the degree of the term. Hence degree of term x cubed y squared is 3 plus 2 equals 5. Similarly for term 3x y squared. Degree of term 3xy squared is 1 plus 2 equals 3. Term 5xy. Degree of term 5xy is 1 plus 1 equals 2. Term 7. Degree of term 7 is 0. Like and unlike terms. Like terms. All the terms containing the same variables with the same degree are called like terms. Example: y, 5y, 9y. Here we can observe, we have same variables, y, and same degree, 1. Unlike terms. Terms which have different variables, or same variables raised to different powers, are called unlike terms. Example: 2xy, 2ab, 2x squared y, 5xy squared are unlike terms. Addition of algebraic expressions. We have two methods. Horizontal method. Example: a plus b, minus a plus b, a minus b, minus a minus b. Since we are in the topic of addition of algebraic expressions, so we will execute addition operation. Now, first arrange all the terms in a horizontal line. A plus b, plus, minus a plus b, plus, a minus b, plus, minus a minus b. And then add by combining the like terms. After executing the addition operation, we get the result as 0. Column method. Example: minus x squared minus y squared minus z squared, to x squared plus 3y squared plus 4z squared, minus x squared minus z squared. Write the like terms in columns and then add them. Minus x squared minus y squared minus z squared. 2x squared plus 3y squared plus 4z squared. Minus x squared minus z squared. After executing addition operation, we get the result as 0 plus 2y squared plus 2z squared. Subtraction of algebraic expression. Example: subtract 2x minus 8x squared minus 9 from 5x squared plus 3x plus 4. Horizontal method. We execute subtraction operation. 5x squared plus 3x plus 4 minus 2x minus 8x squared minus 9. Now, first we open the bracket. And then group the like terms. And then add them. Remember the rule of sign convention when we open the bracket. Minus into minus is plus. Minus into plus is minus. So, we get the result as 13x squared plus 1x plus 13. Column method. We write the like terms in column, and then subtract them. 5x squared plus 3x plus 4. Minus 8x squared plus 2x minus 9. Now, when executing subtraction operation, the sign of all the terms in the algebraic expression being subtracted are reversed. So here, minus will reverse to plus, plus reverse to minus, and minus will reverse to plus. So, we get the result as 13x squared plus 1x plus 13. What must be subtracted from 3a squared plus 4b squared minus 6ab to get 8b squared minus 4a squared plus 2ab? Let us subtract x from 3a squared plus 4b squared minus 6ab to get 8b squared minus 4a squared plus 2ab. So, 3a squared plus 4b squared minus 6ab minus x equals 8b squared minus 4a squared plus 2ab. X equals 3a squared plus 4b squared minus 6ab minus 8b squared minus 4a squared plus 2ab. Therefore, x equals 7a squared minus 4b squared minus 8ab. A ribbon is 10x minus 8 meters long. A length of 7x minus 5 meters is cut from it. How much ribbon is left? Let AC be the length of the ribbon. That is 10x minus 8 meters. Let AB be the length cut from the ribbon. That is 7x minus 5 meters. We have to find BC, which will be the ribbon left. So, length of ribbon equals AC equals 10x minus 8 meters. Length cut from the ribbon equals AB equals 7x minus 5 meters. Ribbon left equals BC equals AC minus AB. BC equals 10x minus 8 minus 7x minus 5. Therefore, BC equals 3x minus 3 meters. This ends our topic on algebraic expressions. Welcome back. Today our topic is exponent. So, what does it mean when we say exponent? Exponent indicates how many times a number is being multiplied by itself. Here indicates means, point out, or shows. Example, 5 into 5 into 5 equals 5 raised to the power 3. And here, 3 indicates exponent, and it shows 5 is multiplied 3 times by itself. Now if a is a rational number, that is, -1, 0, 1, 3 by 2 etc. And m is a positive integer, that is, we know integers are -2, -1, 0, 1, 2, 3 etc. And here m is a positive integer, so positive integers are 1, 2, etc. And we know this is natural number. So from this we know positive integers are simply the natural numbers. Then, a into m times equals a raised to the power m. Now, to realize this more clearly, we multiply 2 4 times, and this can be written as 2 raised to the power 4. And when we multiply 2 times, it can be expressed as 2 raised to the power 2. So, now when we multiply 2 m times, this can be written as 2 raised to the power m. Similarly multiplying a m times equals a raised to the power m, where m is the exponent and a is the base. Here, a is the number which is multiplied repeatedly and is termed as base. M is the number of times the base is repeated and is termed as exponent or power or index. This notation of writing the product of a rational number by itself several times is called exponential notation. In mathematics, notation means a method used to express mathematical concepts, operations, relations, etc. Laws of exponents. Law 1, or product law. If x is a non-zero rational number, and a and b are positive integers, then x raised to the power a into x raised to the power b equals x raised to the power a plus b. Here we observe, if the base are same, then powers are added under multiplication of numbers. Law 2, or quotient law. If x is a non-zero rational number, and a and b are positive integers. Case 1, when a is greater than b. X raised to the power a divided by x raised to the power b equals x raised to the power a minus b. Now, how did we get x raised to the power a minus b? Consider x raised to the power a divided by x raised to the power b equals x raised to the power a into 1 by x raised to the power b. Since we already know, division is the inverse of multiplication. 1 by x raised to the power b can be written as x raised to the power minus b. So, x raised to the power a divided by x raised to the power b equals x raised to the power a into x raised to the power minus b. Now, applying law 1 or product law. X raised to the power a into x raised to the power minus b equals x raised to the power a plus minus b equals x raised to the power a minus b. Case 2, when a is lesser than b. X raised to the power a divided by x raised to the power b equals 1 by x raised to the power b minus a. So consider x raised to the power a divided by x raised to the power b equals x raised to the power a into 1 by x raised to the power b. Now, if 1 by x raised to the power a equals x raised to the power minus a, 1 by x raised to the power minus a equals x raised to the power a. So, x raised to the power a divided by x raised to the power b equals 1 by x raised to the power minus a into 1 by x raised to the power b equals 1 by x raised to the power minus a into x raised to the power b. Now, applying law 1 or product law. X raised to the power a divided by x raised to the power b equals 1 by x raised to the power b minus a. Law 3 or negative exponent law. If x is a non-zero rational number and a is a negative integer, then x raised to the power minus a equals 1 by x raised to the power a. Law 4 or power of a power law. If x is a non-zero rational number and a and b are positive integers, then x raised to the power a is raised to another power b equals x raised to the power ab. Consider x raised to the power a is raised to another power b. Here, x raised to the power a means base x is multiplied by itself a times. X raised to the power a is raised to another power b means x raised to the power a is multiplied by itself b times. Example, 5 raised to the power 2 is raised to another power 3 is same as 5 raised to the power 6. Now to have this conclusion, we simplify 5 raised to the power 2 is raised to another power 3 equals 5 raised to the power 2 into 5 raised to the power 2 into 5 raised to the power 2. We have 5 multiplying by itself 6 times. So, 5 raised to the power 2 is raised to another power 3 equals 5 raised to the power 6. Law 5 or zero exponent law. If x is a non-zero rational number, then x raised to the power 0 equals 1. Example, 5 raised to the power 0 can be written as, say, 5 raised to the power 2 minus 2 equals 5 raised to the power 2 into 5 raised to the power minus 2 equals 5 raised to the power 2 divided by 5 raised to the power 2. Therefore, 5 raised to the power 0 equals to 1. Hence, x raised to the power 0 equals 1. Law 6, or power of 1, law. If x is a non-zero rational number, then x raised to the power 1 equals x. Law 7, or power of a product law. If x and y are non-zero rational numbers, and a is a positive integer, then x raised to the power a into y raised to the power a equals x into y raised to the power a. Example, 2 raised to the power 2 into 3 raised to the power 2 can be simplified as 2 into 2 into 3 into 3 equals 2 into 3 into 2 into 3 equals 6 into 6 equals 6 raised to the power 2. So, 2 raised to the power 2 into 3 raised to the power 2 equals 2 into 3 raised to the power 2, which is same as 6 raised to the power 2. Now, power of a quotient law. X by y raised to the power a equals x raised to the power a divided by y raised to the power a. Example. Simplify and write in exponential form. 5 by 7 raised to the power 7 divided by 5 by 7 raised to the power 7. First observe which law can be applied here. Now, applying quotient law. That is x raised to the power a divided by x raised to the power b equals x raised to the power a minus b. Here, the base x equals 5 by 7 and exponents a equals 7 and b equals 7. So, 5 by 7 raised to the power 7 divided by 5 by 7 raised to the power 7 equals 5 by 7 raised to the power 7 minus 7 equals 5 by 7 raised to the power 0. Now, applying zero exponent law. That is, x raised to the power 0 equals 1. So we have 5 by 7 raised to the power 0 equals 1. Therefore, 5 by 7 raised to the power 7 divided by 5 by 7 raised to the power 7 equals 1. Example. Express each of the following with positive integers as exponents. A raised to the power 4 into a raised to the power minus 6. Applying product law. That is, x raised to the power a into x raised to the power b equals x raised to the power a plus b. So, a raised to the power 4 into a raised to the power minus 6 equals a raised to the power 4 plus minus 6 equals a raised to the power 4 minus 6 equals a raised to the power minus 2. Therefore, a raised to the power 4 into a raised to the power minus 6 equals 1 by a raised to the power 2. Example. Express each of the following with negative integers as exponents. Y raised to the power 2 into y raised to the power 3 by y raised to the power 4. First let's simplify y raised to the power 3 divided by y raised to the power 4 to make it more simple. So, applying quotient law to y raised to the power 3 divided by y raised to the power 4. That is. So, y raised to the power 3 divided by y raised to the power 4 equals y raised to the power 3 minus 4. Hence, y raised to the power 3 divided by y raised to the power 4 equals y raised to the power minus 1. Therefore, y raised to the power 2 into y raised to the power 3 divided by y raised to the power 4 equals y. So, we have to express y raised to the power 2 into y raised to the power 3 divided by y raised to the power 4 with negative integers as exponents. Now, y can also be expressed as 1 by y raised to the power minus 1. Therefore, y raised to the power 2 into y raised to the power 3 divided by y raised to the power 4 equals 1 by y raised to the power minus 1. Example. Find the value of 6 raised to the power 0 plus 17 divided by 2 raised to the power 5. 6 raised to the power 0 plus 17 divided by 2 raised to the power 5 equals 1 plus 17 divided by 2 raised to the power 5 equals 18 divided by 2 raised to the power 5 equals 9 by 16. Example. Find the value of x if minus 2 by 5 raised to the power 8 into minus 2 by 5 raised to the power 4 equals minus 2 by 5 raised to the power x minus 1. First, we will make the base on the left-hand side and right-hand side equal. Apply product law on LHS. Minus 2 by 5 raised to the power 8 into minus 2 by 5 raised to the power 4 equals minus 2 by 5 raised to the power 8 plus 4. Now, we equate the value obtained on LHS with RHS. Therefore, minus 2 by 5 raised to the power 8 plus 4 equals minus 2 by 5 raised to the power x minus 1. So, now we have the same base on LHS and RHS, that is, base equals minus 2 by 5. Since we now have the same base, now consider only the power. So, 8 plus 4 equals x minus 1. Therefore, x equals 13. This ends our topic on exponents. Welcome back. Today our topic is commercial mathematics. In this topic we have
proportion, unitary method, percentage, profit and loss, and simple interest.
Proportion.
When two ratios are equal, their terms are said to be in proportion.
Proportions are denoted by the symbol.
If A by B equals C by D, then A, B, C, and D are in proportion and can be written as
A into B equals C into D.
Therefore, product of extremes equals product of means.
Continued proportion.
Any three quantities are said to be in continued proportion if the ratio between the first and the second is equal to the ratio between the second and the third. Similarly, for quantities, in continued proportion will have the ratio between the first and the second equal to the ratio between the third and the fourth. If A, B, and C are in continued proportion, then A by B equals B by C, and B square equals A, C, or vice versa.
Example.
If the angle of a triangle are in the ratio 4:4:2, find the value of each angle.
We know there are three angles in a triangle. And sum of all the angles in a triangle is 180 degree.
Given, the angle of a triangle are in the ratio 4:4:2. This means, here 180 degree is divided into three parts, in the ratio 4:4:2. So, an unknown variable along with each part of the ratio will give us the value of each angle.
Let's term the unknown variable as x.
Sum of all the angles in a triangle equals 180 degree. For x plus 2x equals 180 degree.
X equals 18. Therefore, the angles are: for x equals 72 degrees. For x equals 72 degrees. 2x equals 36 degrees. Now, let's look into unitary method.
Unitary method is a mathematical technique used to find value of one quantity, and then use that value to find the value of multiple quantities. Now, if we have to find the value of one quantity from the given value of multiple quantities,
we apply division operation.
If we have to find the value of multiple quantities from the given value of one quantity,
we apply multiplication operation.
Unitary method involving direct variations.
This type describes the direct relationship between two quantities.
In simple words, if one quantity increases, the other quantity also increases. And if one quantity decreases, the other quantity also decreases.
Unitary method involving inverse variations.
If one quantity increases, the other quantity decreases, or vice versa.
Example. Lotha will take 10 days to dig a well. Seema will take 15 days to dig the same well. In how many days will they be able to dig the well if they work together? Now, remember, power is defined as the rate of doing work, which is the amount of work done per unit of time. Meaning, it measures how quickly work is being performed. So from the above statements, we have rate of work equals amount of work done per unit of time. Or, we can rearrange this equation as time equals amount of work done by rate of work. Here, we count work as 1. So, rate of work for Lotha equals 1 by 10. Rate of work for Seema equals 1 by 15. Now, rate of work by Lotha and Seema together will be 1 by 10 plus 1 by 15 equals 1 by 6. Therefore, time equals 1 divided by 1 by 6 equals 6 days. Now, next is percentage. Percent means out of 100. Converting fractions, ratios, and decimals into percentage. To convert a fraction into a percent, we multiply the fraction by 100 and assign percent symbol. Example, 2 by 4. This can be simplified as 9 by 4 equals 9 by 4 into 100 equals 225%. To convert a ratio into a percent, first, we write the ratio as a fraction. Then we multiply the ratio by 100 and assign percent symbol. Example, 7.5 is to 22.5.
This can be simplified as 7.5 by 22.5 equals 75 by 225 into 100 equals 33.3%.
To convert a decimal into a percent, we multiply the decimal by 100 and assign percent symbol. Example, 0.004. So, 0.004 into 100 equals 0.4%. Converting percentage into fractions, ratios, and decimals. To convert a percent into a fraction, we divide the number by 100 and drop the percent symbol. Example, 22.5%. So, 22.5 by 100 equals 9 by 40. To convert a percent into a ratio, divide the number by 100 and drop the percent symbol. Example, 0.15%. So, 0.15 by 100 equals 3 by 2000 equals 3:2000. To convert a percent into a decimal, divide the number by 100 and drop the percent symbol. Example, 33 by 3%. This can be simplified as 100 by 3% equals 100 by 3 divided by 100 equals 1 by 3 equals 0.33. Now, to find percentage of a quantity. For obtaining the percentage, say y% of a number, say x, we multiply x by y divided by 100. So, y% of x equals y by 100 into x. Example, 33 by 3% of 200. This can be simplified as 100 by 3% of 200 equals 100 by 3 into 100 into 200 equals 200 by 3 equals 66.66. Example. Miss Al saves 30% of her salary if her expenses is 14,000. Find the total income and savings. Let X be Miss Al's salary, which is her total income. Now, assume this circle represents Miss Al's salary, and she spends 14,000, which is represented by the white section. And she saves 30% of her salary, which is represented by the blue section. So, her total income is 30% of total income plus 14,000. X equals 30 by 100x plus 14,000. 100x equals 30x plus 14,000 into 100. Total income equals 20,000. Now, savings equals 30% of x. Therefore, savings equals 6,000. Example. Divide 16 toffees between Miss Angami and Miss Al, so that they get 25% and 75% respectively. Here, Miss Angami gets 25% of 16 toffees. Equals 25 by 100 into 16 equals 4 toffees. Miss Al gets 75% of 16 toffees. Equals 75 by 100 into 16 equals 12 toffees. Now, profit and loss. Here, remember these points. Cost price is the price at which an item is purchased or produced. Selling price is the price at which an item is sold. Profit is the difference between the selling price and the cost price. That is when the selling price is higher. Loss is the difference between the cost price and the selling price. That is when the cost price is higher. So, profit equals selling price minus cost price. Loss equals cost price minus selling price. Now, in case of no profit no loss situation, selling price equals cost price. Next is profit percentage. Profit percentage is the amount of profit expressed in terms of percentage. Now, profit is based on cost price. Why is this so? Because cost price provides a baseline for understanding or measuring the financial success of a transaction or business. To express profit as a percentage, we need to determine what portion of the cost price is the profit. We have profit equals selling price minus cost price, and profit percent equals profit by cost price into 100. Loss percentage. Similar to profit percent, loss is based on the cost price. Loss percent equals loss by cost price into 100.
This formula expresses the loss as a percentage of the original cost price.
Example.
A fruit seller bought 2 dozen of oranges at rupees 45 per dozen. 13 oranges are found rotten. At what rate should he sell each orange to gain 10%? We know 1 dozen orange equals 12 oranges. So, 2 dozen orange equals 12 plus 12, or 2 into 12 equals 24 oranges. Given cost price of 1 dozen of orange equals rupees 45. So, cost price of 2 dozen of orange equals 2 into 45 equals rupees 90, which is the total cost price. So, out of 24 oranges, 13 were rotten. Now, good oranges equals 24 minus 13 equals 11 oranges.
So only 11 oranges can be sold.
Now, desired profit equals 10% of total cost price.
Equals rupees 9.
So, desired selling price equals desired profit plus cost price.
Equals rupees 99.
Now, only the good oranges can be sold. So, selling price per orange equals rupees 99 by 11 equals rupees 9. Therefore, the fruit seller should sell each orange at rupees 9 to gain 10% profit.
Simple interest. Now, if we borrow money from a bank. Principal is the money which is borrowed. Time
is the period for which the money is borrowed. That is, you have to return the borrowed money within a specific period of time.
Interest rate, or rate of interest,
is an agreed percentage of the sum borrowed at the time of taking the money throughout the loan period.
Simple interest, or interest,
is the additional money paid on a principal amount over a specific time period. Interest equals principal into rate into time.
Amount is the money given back, which includes the interest and principal.
Amount equals principal plus interest.
Example. Miss Al borrowed rupees 3 lakhs from a bank to buy a tractor.
Find the amount she would pay after 3 years 6 months at 15% per annum. Given, principal equals rupees 300,000.
Time equals 3 years 6 months. Now, we can represent time either in months or years.
So, time equals 3 years 6 months. This can be written as
3 into 12 plus 6 months. Time equals 42 months.
Or, time equals 3 years 6 months. This can be written as
3 plus 6 divided by 12 years. Time equals 3.5 years.
Now, rate equals 15% per annum.
Here annum means per year or annually.
Since rate is given as per annum, it is also appropriate to denote time in years too. So we will use time equals 3.5 years. Rate equals 15 by 100 into 1 equals 15 by 100. Amount equals principal plus interest. Now, interest equals principal into rate into time.
Interest equals rupees 157,500.
Therefore, amount equals rupees 457,500.
Example.
If rupees 10,000 becomes rupees 11,000 after 2 years at a certain rate of interest, find the rate of interest. Given, principal equals rupees 10,000.
Amount equals rupees 11,000. Time equals 2 years. Here, we have to find the rate of interest.
We know amount equals principal plus interest. So, interest equals rupees 1,000. Also, interest equals principal into rate into time.
So, rate equals 0.05 per annum.
Therefore, rate equals 5% per annum.
This ends our topic on commercial mathematics. Welcome back.
Today our topic is data handling. To brush up your basics, check out data handling in Class 6 playlist. Representative or central values.
Consider the statements.
Miss Angami spends on an average of about 5 hours on Monday and Tuesday for her studies every week.
What does this statement tell you?
So, by average, we understand that Miss Angami usually studies for 5 hours on Monday and Tuesday. On Monday she may study for less number of hours. and on Tuesday she may study longer. So, maybe, on Monday she studies for 4 hours. And on Tuesday she studies for 6 hours. So, this is the group of observation or group of data we have. And average equals 4 plus 6 by 2 equals 5. So, we can say, here 5 is the central tendency of the data. Since 5 lies between the lowest value, 4, and highest value, 6. Thus, we observe that average is a number that represents or shows the central tendency of a group of observation or group of data. Average lies between the lowest value and highest value of the given data, which is the central tendency. So we say, average is a measure of the central tendency of the group of data. This means a summary measure that attempts to describe a whole set of data with a single value that represents the middle or center of its distribution. Different forms of data need different forms of representative or central value to describe it. One of these representative value is the arithmetic mean. Arithmetic mean, or mean. Average, or arithmetic mean, or simply mean. Equals sum of all observations by number of observations. Range. The difference between the highest and the lowest observation gives us an idea of the spread of the observations. We call the result range of the observation. Range equals highest observation minus lowest observation. Mode. As we have said, mean is not the only measure of the central tendency or representative value. For different requirements from a data, other measure of central tendencies are used. Example. To find the weekly demand for different sizes of shirts. A shopkeeper kept records of sales of sizes 90 centimeters, 100 centimeters, 110 centimeters. Following is the record for a week. If Miss Al found the mean number of shirts sold, do you think Miss Al would be able to decide which shirt sizes to keep in stock? Mean equals total number of shirts sold by number of different sizes of shirts. Here there are 3 different sizes of shirts. So, mean equals 30 by 3 equals 10. Should Miss Ao obtain 10 shirts of each size? If she does so, will she be able to cater to the needs of the customer? So, let's say Miss Ao, on looking at the record, decides to procure shirts of size 90 centimeters and 110 centimeters. Also, another possibility is, Miss Ao says the most popular size of shirt I sell is 90 centimeters. Observe here, Miss Ao is looking at the shirt size that is sold the most. This is another representative value. The highest occurring event is the sale of size 90 centimeters. This representative value is called mode of the data. The mode of a set of observations is the observation that occurs most often. Median. Example. A group of 7 students with height 15, 12, 10, 12, 20, 16, 12. The teacher wants to divide the class into 2 groups, so that each group has equal number of students. One group has students with height lesser than a particular height. The other group has students with heights greater than the particular height. How would the teacher do that? Let's see the various options the teacher has. Teacher can find the mean. Mean equals 97 by 7 equals 13.8. So, if the teacher divides the students into 2 groups, on the basis of this mean height. Group 1 will be 12, 10, 12, 12. Group 2 will be 15, 20, 16. Which is an unequal grouping. Second option is to find mode. Mode equals observation with highest frequency. So, mode equals 12. They will have 1 student below mode, and 6 students at mode and above the mode, which is an unequal grouping. So, let us think of an alternative representative value. Here, we arrange the students in ascending order or descending order of height. 10, 12, 12, 12, 15, 16, 20. The middle value in this data is 12. Because this value divides the students into 2 equal groups of 3 students each. This value is called median. Median value refers to the value which lies in the middle of the data. So, the teacher decides to keep the middle student as a referee in the game.
Now consider n equals number of observations. If n is odd, median equals n plus 1 by 2 term. Here, n equals 7, which is odd. So, median equals 7 plus 1 by 2 equals 8 by 2. Equals fourth term. Here the fourth term is 12. Therefore, median equals 12. Now, if n is even, first find n by 2 and n by 2 plus 1. So median will be n by 2 plus n by 2 plus 1 divided by 2 term. Thus we realize that mean, mode, and median are the numbers that are the representative values of a group of observations of data. They lie between the maximum and minimum values of the data. They are also called the measures of the central tendency. Example.
The runs scored by a cricket player in 10 innings are as follows:
79, 91, 76, 77, 91, 33, 77, 76, 33, 77.
Prepare a frequency distribution table and
find the mean, mode and median of the given data. Given. Sort the data in ascending order. 33, 33, 76, 76, 77, 77, 77, 79, 91, 91. Here we have two columns, runs and frequency. 33, the frequency it occurs is 2 times. 76, it also occurs 2 times. And so on. Here the total number of observation is 10. Mean equals sum of all observations by total number of observation. Equals 710 by 10. Mean equals 71. And mode equals observation with highest frequency. Therefore, mode equals 77.
Now, median equals middle value in this data, equals 77, refer the frequency table.
Or, here n equals 5, which is odd. So median equals n plus 1 by 2, term. Median equals third term.
Therefore from table, third term is 77.
So, median equals 77. Example. Find the value of x if the mean of the following data is 10. 6, 7, 9, 11, x, 12, 13, 14. Given, mean equals 10.
Now, mean equals sum of all observations by total number of observations.
So, 72 plus x equals 80. Therefore, x equals 8. This ends our topic on mean, mode, and median. In the next video we will cover bar graphs and probability. Welcome back. Let us continue with our topic on data handling. Subtopic, chances and probability. Chances and probability. Consider the statements. There is no chance of rain in Kohima. Probably tomorrow will be a sunny day in Dimapur.
It is quite probable that Kohima will win the Cleanest District in Nagaland award.
In all these statements, we are not sure about the occurrence of the event. There is an element of uncertainty associated with these statements.
Such types of events can be predicted with the help of the concept of probability. So, probability provides a numerical measure of the chance of the occurrence of a phenomenon, or probability enables us to take a decision under conditions of uncertainty with a calculated task.
Example.
Lotha, Ao, Sema, and Gami are 4 students running for the head boy of the school.
What are the chances that Lotha will be selected? There are 4 students, and all have an equal chance of selection. Since all have equal chance of selection, possible event, or possible outcome, equals 4. And chance of selection of Lotha equals 1 out of 4. Therefore, probability of Lotha's selection equals 1 by 4. Probability of Ao's selection equals 1 by 4. Probability of Sema's selection equals 1 by 4. Probability of Angami's selection equals 1 by 4. Hence, the chance of an event occurring is called the probability of the event. Now let P, E, represents probability of an event.
So, probability of an event equals number of ways the event can happen by total number of possible outcomes. Or, probability of an event equals favorable outcome by total outcome.
In the above example, number of ways for Lotha's selection equals 1. Total number of possible outcomes equals 4, since there are 4 students. Therefore, probability of Lotha's selection equals 1 by 4. Impossible events. There are certain events that never occurs. Example, getting a number 7 when a dice is rolled. Events which cannot occur are called impossible events. Now, probability of impossible event is always 0. Sure events. Some events definitely happen. Example, if we throw a ball upwards, then it will certainly return to the earth. Hence, probability of sure event equals 1. So, probability of an event always lies between 0 and 1. In any experiment, the sum of the probabilities of all events is always equal to 1. From the previous example, we know. Adding these probabilities together, we get. Thus, the sum of the probabilities of all events is 1. Experiments, outcomes, and sample space. Toss a coin to get head up or tail up. Throw a dice, you get 6 possible scores, that is, 1, 2, 3, 4, 5, and 6. The act of tossing a coin or throwing a dice is called an experiment. The score that you get is called an outcome. Example, you throw a dice. And you get 4. The list of all possible outcomes is called the sample space, and is denoted by S. Example, if you toss a coin, there is only 2 possible outcome, head or tail. So, sample space, S, equals H, T. Here, the reason we use curly bracket is just for clarity and by tradition, that is, just a long-established convention in mathematics. Example, when a dice is rolled, there are 6 possible outcomes. So, sample space equals 1, 2, 3, 4, 5, 6. Example, a box contains 10 green, 7 red, 8 yellow, 3 blue colored balls. If a single ball is chosen at random from the box, find the probability of choosing the following: a green ball, a red ball, a yellow ball, a blue ball. Total number of balls equals 10 plus 7 plus 8 plus 3 equals 28. We know probability of event equals number of ways the event can happen by total number of possible outcomes. So, for a green ball, total outcome equals total number of balls equals 28. Here, out of 28 balls, there are 10 green balls. So number of ways the event can happen, that is, choosing a green ball equals 10. Therefore, probability of choosing a green ball equals 10 by 28 equals 5 by 14. Similarly, probability of choosing a red ball equals 7 by 28 equals 1 by 4. Probability of choosing a yellow ball equals 8 by 28 equals 2 by 7. Probability of choosing a blue ball equals 3 by 28. Example, in a city, 100 families with 2 children were selected randomly, and the following data was collected. Find the probability of a family at random having 1 boy, 2 boys, 3 boys. Total number of families equals 100. So for 1 boy, number of families having 1 boy equals 20, here refer the data in the table. Therefore, probability of a family having 1 boy equals 20 by 100 equals 1 by 5. Similarly, probability of a family having 2 boys equals 55 by 100 equals 11 by 20. Probability of a family having 3 boys equals 25 by 100 equals 1 by 4. This ends our topic on data handling. Thanks for watching. Check out our other videos and subscribe to our YouTube channel. Until then, stay safe and live healthy.